Hello there, I'm Mr. Math Guy, and today we'll be taking a look at a 10-minute video on the meaning of volume. What is volume? Well, if you think about a three-dimensional object, volume is how much space is inside of this three-dimensional object. It's measured in cubic units. How much is needed to fill the interior of something. Recently, my father and I were talking about electric power costs, and my electric power bill was considerably lower than his this past month, and we both live in basically the same area, the same temperature, and we were trying to, discussing why mine was a little bit better. Probably I have a newer unit, and it's probably more efficient. But also his house is a little bit bigger in square footage. It's not that much larger than mine in square footage, but it is a little bit larger of a house. But still didn't seem to reconcile why his was so much higher than mine was. And then he was like, but my square footage is about the same as yours. Why is mine so much more? And then I thought, well, I know why. Because you have cathedral ceilings throughout your house. These are the ceilings that are the tall ceilings, not a regular 8-foot ceiling. His ceilings are 10, 15 feet up in the air. And so although our square footage of houses might be similar, the volume in his house is a lot more than the volume of my house. And so therefore, to heat his house or to cool his house, he's cooling a lot bigger of an area or a lot bigger of a volume, because he's not just doing a certain length and width. It's also measured in height. He has more air to heat or to cool in his house than I do, just because of his vaulted ceilings. So that's kind of what volume is how much it would take to fill up some kind of a solid, maybe some kind of a box. How much space could you put stuff in a box? All right. So volume is measured in length, width, and height. It's three-dimensional, so these are always measured in cubic units. Whereas when we're talking about area, it's just length and width, which is square units. So this is kind of a meaning of volume. So let's take a look at a couple of postulates and theorems and a couple of example problems on how to calculate volume. All right, let's look at these statements that I've put up on the screen. First, kind of a definition of volume. Volume is the number of cubic units needed to fill up the interior completely, as I kind of just discussed with the heating and cooling of a house. Every solid has a volume given by a positive real number. So if you have a solid, it has some kind of a positive volume. It can have a negative volume, it can have a negative square footage, and it's a real number. Congruent solids, that means solids that are identical to each other. Congruent solids have the same volume. All right, so if you have a trash can and you have a trash can that's exactly like it, then they both contain the same amount of volume. And then if the interior of two solids do not intersect, so if you have a trash can and you have a bowl of some sort, the volume of both the trash can and the bowl would be the sum of the two volumes, because they don't intersect. Now, if the bowl was in the trash can, then those would be intersecting volumes, so it wouldn't be the sum of the volumes. But if they're separated, then the sum of the volume is the union of their sum of the volumes. So these are some kind of important statements here when we take a look at volume. Now, one of the first things that we want to take a look at is there's a lot of formulas when dealing with how to figure out volume. So anytime you're dealing with area, you just have to memorize and learn a bunch of formulas. Same thing with volume. You're just going to learn a bunch of formulas and how to apply them. So there's two here that we're going to show you in this video. And these are really important, pretty basic. You might even know them already. The first is the volume of a cube. So if we have a cube, sorry about that, it's cubed. I don't want to have the volume of a cube. Two important formulas here. The volume of a cube is equal to, V stands for volume, is equal to the letter E cubed. Now this letter E stands for the edge, all right? So if we have some kind of a cube, the length, width, and height of something are all the same, then it's just the edges will all be the same. You just take that edge and cube it to the third power, right? Now, the second one that's pretty important is the volume of a rectangular prism. And we'll draw pictures of these so you can see both as well. Rectangular prism. The volume of a rectangular prism is simply just L times W times H, or length times width times the height. All right, so let's take a look at how to calculate some example problems with cubes and rectangular prisms. In this first one, in this example, we have a cube here. You got the length is 4, the width is 4, and the height is 4. All right, it is a rectangular prism, but it's a special rectangular prism. So then we just use our formula for cube. V is equal to E cubed. So in this particular problem, V is equal to 4 times 4 times 4, which is 64, and we would put cubic units. You can abbreviate CU for cubic. All right, so this would contain 64 cubic units. So there's 64 cubic units of space that could fit down inside of this cube. Again, we're not talking about the surface area, all right? We're talking about how much space could be put, or how much material, or how much water, or how much, how many things could be put inside of this cube until it would fill completely up. All right, so 64 cubic units. Let's take a look at another problem. This is the next example. I have a rectangular prism. Okay, it's a prism. Bases are the same. You have actually a square on both sides, and the sides, the lateral surface sides, are made up of rectangles. So volume here is equal to LWH, length times width times height. So it's just V is equal to length of 3, width of 3, and the height of this was 9. So 3 times 3 is 9, times 9 is 81 cubic units. 81 cubic units. So you just need to figure out the missing part and fill it in and plug it into your formula. So no E, or find L, W, and H. All right, let's take a look at maybe a couple more examples with volume. Problem like this is, let's say we have a bedroom that is a 15 by 10 by 8. Pretty standard size bedroom in most people's houses, I would assume. 15 feet long, 10 feet wide. All right, and then it would be 8 feet high. All right, so a height of 8 feet. So if this is the floor plan, this is a 15 by 10, and you can't really tell, but we're saying it's 8 feet high. Really, what it basically boils down to is basically it's just some kind of rectangular cube. All right, now I would have it, the numbers different if I was going to draw it like this. It'd be 15 this way, and it would be 8 here. All right, 15 by 10 by 8. So this is kind of how your room would look. We don't normally think of our room as a rectangular prism, but it is. So how many cubic boxes? How many cubic foot boxes? So if I had a cubic foot box, 1 foot by 1 foot by 1 foot. How many of these boxes could I stack in here? Okay, here's one, here's one, here's one, here's one, here's one. And you can go up, keep going up all the way, and until that all this whole room was filled with boxes. Well, it's basically just wanting the volume. Volume is 15 times 10 times 8. So it's 150 times 8, which is 1,200. So you'd have 1,200 cubic feet of space, or there would be 1,200 cubic feet or cubic foot boxes that could fit into this bedroom.